Okay, we're going to look at some of this integration with parametrics. So for our example, what we're going to say is that the curve C has parametric equation and it's going to be x equals t times 1 plus t and y equals 1 divided by 1 plus t, where t is bigger than or equal to 0. So a parametric, if you remember, is when x and y are both described in terms of other variables. X and y are both described in terms of t. And the question defines the region R, which is bounded by C, and the lines x equals 0 and x equals 2. And there's two parts to the question. Part A, find the exact area of R, and part B, find the volume of the solid formed when R is rotated through 2 pi radians about the x-axis. Okay, if we start with part A then, so if we're trying to find the area of R, so that will be the integral from 0 to 2 of y with respect to x. But remember, when we're doing parametrics, we can't differentiate with respect to x. So what we need to remember from way back the chapter before is that the integral of y dx is the same as the integral of y times dx by dt. So if we put that into this equation, if we know that x equals t times 1 plus t, well, that's the same as t plus t squared. So if we differentiate, dx by dt will just be 1 plus 2t. So the integration, this one over here, will become the integral of y times, y is that, times dx by dt, dt. But be really careful. Remember at that point, these two limits have to be in terms of t. So the limits aren't now 0 and 2 like they were at the top up here. The limits are now going to be something different. So we can find the limits by saying, well, what would happen? Let's look at the lower limit first. The lower limit at the bottom was 0, so that's when x equals 0. So if x is 0, then 0 must equal t times 1 plus t. So either t equals 0 or 1 plus t equals 0, which would mean t equals minus 1. Now if you think back, or you look back up to the top of the question, up here it says t has to be bigger than 0. So if t has to be bigger than 0, we can rule that one out. So the lower limit is 0. Okay, let's look at the upper limit. So the upper limit was originally 2. So that's telling us that when x equals 2, then 2 equals t times 1 plus t, or 2 equals t plus t squared, or t squared plus t minus 2 equals 0, t plus 2, t minus 1, if we factorise. So we can say either, and your two answers here are going to be t equals minus 2 or t equals 1. And again, it told us at the top that t was bigger than or equal to 0, so we can rule out that one. So your top limit must be 1. So what we've ended up doing, our integration has become the integral from 0 to 1 of 1 plus 2t over 1 plus t dt. Okay, so we want to integrate this. This fraction has got the same dimension of t on the top and bottom, the same power of t on the top and bottom. So what I need to do is do a little division first, see whether I can change this into a number and a fraction. So what I want to do is if I write doing 2t, if I write it as 2t plus 1, I'm dividing that by the bottom line, which is the same as t plus 1. So to get the numbers of t's, I'm going to have to multiply by 2. I get 2t plus 2. If I subtract to get my remainder, 1 take away 2 is minus 1. So I can write this as a big number 2 minus 1 over 1 plus t dt. That's what I'm going to now integrate. So if I integrate that with respect to t, 2 becomes 2t, and that becomes minus log of 1 plus t between 1 and 0. And then all I'm going to do is put in my limit. So if I put in my limits to that, I'm going to get 2 minus log of 2 minus, and then it's going to be 0 minus log of 1. And log of 1 is just 0, so that just comes out as 2 minus log 2.